doesn't. And remember that in 2 Peter, the Bible tells us that to God, 1,000 years is like a day. So God could have done this any way he wants. But still, I think it's an important discussion. And the main reason it's important is that an old Earth is critical to evolutionary theory. So every problem we talked about in the first couple of weeks was answered with, it just took a lot of time. So if you take away a lot of time, I really don't need to answer anything else to evolutionists. If we don't have the time, evolution didn't happen. Even if we did, it didn't happen, by the way. I also believe a young Earth fits much better with biblical history, but I certainly don't base my faith on that. Having said that, the more I study, the more confident I am that the Bible is clearly telling us the Earth is young, and actually the Bible's quite clear that it is, and goes to great lengths to make it clear that it is, and efforts to make it look older actually chip away at the infallibility of the Bible in general. So before I talk about all the evidences for a young Earth and whatnot, are there any residual questions from what we talked about on the Big Bang? Perfect, good, because I probably couldn't answer them. The slides are 2 weeks old. So, all right. So let me look at I'm really going to try not to trip on this tonight. Let's look at what the biblical history of the Earth is. So let's talk about how the Bible outlines this. The creation week, as we've talked about, is one literal week. From creation to the flood, according to Genesis 5, was 1,656 years. And then the flood to Abraham is 300 years, and we have these accounts both in Genesis as well as Chronicles and Luke. Now, the genealogies that they list in these areas are not quite as tight as they could be, so some scholars think this period of 300 years could be as long as 4,000, but for the most part, these genealogies fall into about 300 years. From Abraham to Christ is somewhere between 2,000 to 4,000 years, and again, we have the genealogies from Matthew and from Luke to help validate those dates. And then obviously we all are pretty comfortable knowing that from Christ to present is about 2,000 years. Well, interestingly, the Jewish calendar, which theoretically should have started at the beginning, told us we're in the year 5,781, and that correlates extremely well to the numbers that we have documented here in the Bible. My personal view, as I've told you many times, is the Earth is around 6,000 years old, but very likely not more than 10,000 years old. So let's contrast that with the secular view. Now, before the year 1700, almost everybody accepted what I just showed you before, that the Earth was around 6,000 to 10,000 years old. Geology actually was the first field to start positing an old age for the Earth. And their idea was that these rocks formed very, very slowly. Layers, which we're going to talk about extensively tonight, were laid down over a very long period of time. Lord Kelvin, who I think I've mentioned before, came up with the Kelvin scale, which is our temperature scale for absolute zero. He proposed about 20 to 40 million years for the age of the Earth. He did this around the turn of the century. And he did this based on his theory of the cooling rate of a molten sphere, molten being lava, the Earth being a sphere, and he looked at the cooling rate and said, well, that must be how long it takes to cool. Now, the big change came with radiometric dating. Scientists changed their predictions from the age of the Earth to originally 1.6 billion years old in 1913 to 4.5 billion years old in 1956. Radiometric dating, which we are going to talk about extensively next week, was really the thing that drove this idea that the Earth was much, much older. So let's contrast the two views. Obviously, these are two extremely different lengths of time. It really doesn't matter if it's 6 or 10,000, it's still versus 4.5 billion. We are going to talk, and reconciling them is not really possible. Now, I'm saving that for the very last lecture of this series, but we're going to talk about sort of my issues with old Earth creationism. So the goal for tonight is to explore the various evidence and assumptions around these two views. Now, fundamental to these two views comes down to two terms you're probably going to hear me mention a lot tonight. One is uniformitarianism, and the other is catastrophism. So what am I talking about? Well, uniformitarianism is the concept that processes on the Earth that we observe today mimic what occurred in the past. The quotation you will hear all the time from secularists is, the present is key to the past. The speed and rate and duration of way things occur today mimics what it was in the past. So rates of rock formation that we see today by things like laying down sediment or carving canyons, that tells us how long certain rocks took to form. Uniformitarianism, it's very steady rate. This is the basis for old Earth geology. Now, contrast this with catastrophism. This is the alternative view. This is the view that most of what we see today was formed due to a catastrophic event or multiple events, primarily a flood, in a very short period of time. Ultimately, this discussion comes down to we either have a lot of time and a little water or little catastrophe, or a whole heck of a lot of water and little time. Secularists ascribe to the former, while biblical scholars obviously ascribe to the latter. But I think everybody agrees that it's one of these two things. Do you understand the difference between uniformitarianism and catastrophism? Perfect. All right, see, I'm still working on my pointer. All right, so turning more specifically to geology itself and how geology rates to the age of the Earth, let's talk generically about it. As I mentioned, in the 1700s, that's about the time geology became its own field. And we're all familiar with the idea that rocks and rock layers like the Grand Canyon are quote-unquote known to be millions or even billions of years old. But where did they get that information exactly? Well, interestingly, paleontology was kind of coming along at the same time, and so they often will look at the fossils in certain rock layers to help date the rocks. There are certain fossils that are found at certain levels in the rock layer, and we only see those fossils in that rock layer. So if you've got 10 layers and there's this one creature that's only ever in layer 3, that's called an index fossil. We only find that fossil at that period of time, and so paleontologists tell us how old that fossil is, so anytime we see that fossil, we know the rocks are that old. Now, the rocks without fossils, they use radioisotope dating. We'll talk about that later. But here's the problem with index fossil dating. The rocks date the fossils because we know this rock is this old, so therefore the fossil is this old. So when we find an index fossil in another rock, we know the rock is this old because the index fossil is there. Got it? It's all circular logic. The rocks date the fossils date the rocks. They use this stuff concurrently to date each other without a gold standard reference. Oops, told you I'm still working on it. So I want to talk about the different types of rocks, and then we're going to cover how we think each of these forms. But one of the most basic forms of rocks are called sedimentary rocks. And these are formed by generation of raw materials, by water and weathering, which breaks down boulders and mountains into sand and mud. So you weather away a big mountain, a big boulder, you turn it into sand and mud. And then as water moves along, these materials are precipitated. Precipitated means falls out. Think of this like you have a glass of salt water, and you let the water dehydrate, and you see that salt formation at the bottom as the water leaves away. That's precipitation. Salt and other materials come out of water as water evaporates and disappears. Does that make sense? So this is how sedimentary rocks are formed. You have these materials that are precursors of rocks. They precipitate out of the water, and then they go through a process called lithification. This is cementing or hardening of this sand into these sedimentary rocks. And this cementing and hardening occurs through the pressure of the water and the other debris above it. And this is how we get sedimentary rocks. As opposed to detrital rock, detrital is a fancy term for debris. So what we use here is organic material, dead plants, dead animals. These decay way deep under the ground, under tremendous, tremendous pressure. And what does that form? That forms coal. We know coal comes from living or organic material. What if you use inorganic material? In other words, not plants and animals, but say broken up pieces of other rocks that undergo that same tremendous pressure? Well, you get sandstone. So now there's also something called a chemical sedimentary rock. I don't know if any of you have been in caves and seen cave formation, but these are some classic rocks that we'll see in caves. And these are formed when chemicals actually precipitate out of water. So chemicals, again, being like sodium chloride or salt that dehydrates and you're left behind with salt. Now the classic example here is limestone, and this is formed by precipitation of calcium carbonate, which is a different type of salt, out of the ocean. This is usually what the shells of marine life are made of. So as this shell, if you will, precipitates out of the water, it can form this limestone. Now if we find limestone on land, the assumption is this area was previously covered in water. As I say, another example is these cave formations. So as water passes through the bedrock of the cave, it actually picks up this calcium and this carbonate. As that water evaporates, it leaves behind the rock, and we get these cave formations. So 3 different types of rock, basically. We've got our detrital, our sedimentary, and our chemical sedimentary. So how long does it take to form all of these? Well, the secular view is that these processes occur over millions of years, of course. Coal is commonly taught to be the remains of dinosaurs, which we all know to be 60 million years old. We're also told the Colorado River carved the Grand Canyon over millions of years. Well, to contrast that with the catastrophic view, which is that these processes can occur much more rapidly. So the question is, can they? Can things form rapidly? So let's talk about lithification. Remember, this is the cementing or hardening of the sedimentary rocks. So the formation of these sedimentary rocks occurs when it becomes hardened or cemented, which is lithification. And this occurs when the sediment becomes compacted. So you've got the sediment of debris and sand driving out water, and then it's cemented together usually by something called quartz or calcite. Well, that's the process. We need a lot of pressure, we need quartz, we need calcite. Nowhere in there does it talk about time. These processes really are not time dependent, they're simply condition dependent. So lots of pressure and a cementing agent being there. That's really the only thing we need to make this happen. So do we see this happening? Well, interestingly, they discovered in 1975 this clock in a rock. So this shows part of a man-made rock, which is, man-made clock, which is obviously not millions of years old, encased in solid rock along with seashells. Now, this likely occurred from a shipwreck in time past, but the point of this is it clearly proves that you can get rock in a very short period of time. The clock was obviously not millions of years old. There's also something called the Caso or Coso artifact. This was discovered in 1961 in California. They originally dated this rock, and they said, yep, it's 500,000 years old. But they discovered something funny in it, and so they ended up cutting into it, and they found that it was a spark plug. And it actually was a spark plug from the 1920s. So the scientists said, oh, well, yeah, it's not 500,000 years old, whoops, but it formed quickly because of the rusting and other mechanisms, blah, 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 blah. But what it really importantly shows is, once again, rocks can form very quickly. Obviously, the spark plug is not millions of years old. What about coal formation? How does coal formation actually occur? Well, coal forms from something called peat, which is, I think, a little bit similar to peat moss, but that's highly, highly degraded wood and plant material, again, compressed together very hard. And again, this is thought to take millions of years. However, in laboratory studies, coal can actually be produced in the lab at reasonable temperatures, somewhere between 212 and 390 Fahrenheit, and reasonable pressures. These temperatures and pressures are very well indicative of what the temperature and pressure would be with burial of plant material. So using these experiments to show these kind of temperatures at the depths that we think coal forms, actually you can produce coal in hours to at most weeks. It really doesn't have to take millions of years. So in a real life example, you all are familiar with Mount St. Helens, big explosion. I was really young, for the record. But the areas around Mount St. Helens have actually been investigated, and we're seeing formation of these peat beds. Remember, peat is the precursor to coal, but after Mount St. Helens erupted in the early 1980s, we're seeing these formation of peat beds, and what it looks like to scientists is if there's another eruption, that would quickly turn into coal. Furthermore, the flood itself would have created tremendous heat and pressure, far more than tiny Mount St. Helens could have done, and it would have been due to deep burial. If you get really deep in the earth, the pressure becomes intense and the heat becomes intense, and that's what you need for the formation of coal and oil. So in a lot of ways, the flood clearly explains where our coal and oil come from. Well, what about canyon formation? Again, the Grand Canyon, we all know, took millions and millions of years to form. Just go ask the signs there. However, we have several examples of canyons forming quite rapidly rather than over millions of years. And so as I discuss these, ask yourself what makes more sense when you look at these canyons I'm going to show you and the Grand Canyon. Does a tiny river carving a huge canyon make sense? Or does it make more sense to say there's a huge canyon that resulted in a tiny river? So let's talk about the Little Grand Canyon of the Toutle River. And this is a picture of it up here. So there's a lake called Spirit Lake, and it drains into the Toutle River. Again, going back to Mount St. Helens, with the eruption of Mount St. Helens, the outlet to that river was blocked by about 600 feet of debris. So the river could no longer flow downstream. And then on March 19th of 1982, there was another small eruption that caused a mud flow about 20 miles long, which broke that dam, that 600-foot dam, and pushed all of the debris that had built up and carved this canyon 140 feet deep, which is a 40th the size of the Grand Canyon, in one day. It took 1 day for that to happen. Now, granted, smaller than the Grand Canyon, but still clearly shows that something that scientists would tell us took hundreds of thousands, if not millions of years, occurred in 24 hours. How about the channeled scabland? This is located in eastern Washington state, and this actually started when a glacier formed in the Ice Age, obstructed the Clark Fork River, which formed Lake Missoula. Well, same thing. Eventually, the dam burst, and water, now this is a ton of water, I want you to think about this, the water equivalent to the waters in Lake Erie and Ontario combined rushed through Idaho and Washington over a 2-week period. At its peak flow, this flood represented 15 times the flow of all rivers in the world, and it managed to carve these huge canyons that you'd see demonstrated here. Turning just a little bit, this is one of the most interesting discussions about geology, are these bent rock layers. So has anybody ever here tried to bend a rock or a piece of concrete? Okay. It doesn't work, right? At best, you can break it. You cannot bend rock. So have you ever molded concrete? I'm sure plenty of you have. Works great when it's still wet. Doesn't work at all when it's dry. So how do you explain bent rock if it took millions of years to form? How exactly over millions of years do you bend this to 90 degrees? You don't. Good. I was waiting for somebody. Secular geology teaches that each layer, let me pause for a second, and I practiced this. Google told me it's Kaibab. This is the Kaibab Plateau. This is what the Grand Canyon, these are the layers of the Grand Canyon, basically. You've got your base layers, okay, and then you have something called the Tapete Sandstone. You've got a couple more layers until you end up with the Kaibab Limestone. And part of the Grand Canyon at its higher part is the Kaibab Plateau, and then over time, as you move to eastern Arizona, the elevation drops and you end up in the eastern canyons, but your rock layers are exactly the same, right? You've got each layer bending down. And so the yellow layer up here, the Tapete Sandstone, secularist evolutionists tell us this was laid down 550 million years ago. This top layer, the Kaibab limestone, was laid down about 250 million years ago. So you're looking at 300 million years worth of laying down to get to the Grand Canyon. And then the Grand Canyon, again, cuts through this plateau here, and it's about 7,000 feet above sea level. Now, again, as I mentioned, this same layers that the Grand Canyon cut through, these same layers exist 250 miles away in eastern Arizona, but they're a mile lower in elevation. So we've seen the drop in there. What secular geology teaches us is these rocks were all pushed up. So they all formed, and then about 70 million years ago there was some sort of eruption or fault line or something that pushed all the rocks up in right at this level, pushed it up to form the Kaibab Plateau versus the Eastern Canyons, and then the Colorado River comes through here and carves all of that. Make sense? Well, okay, I mean, but the explanation. So, between these two layers, between where the Grand Canyon is in eastern Arizona, again, huge amount of change over here. These are some seriously bent rocks that supposedly formed over hundreds of millions of years. And actually, you can see almost as I showed you in that picture, 90-degree turns in there. It doesn't make sense. You cannot bend solid rock. Now, secularists give us an answer. They bent up to 9 degrees without fracturing. What they tell us is that the pressure and heat generated from the rock being buried so deeply actually almost melted the rock and allowed it to bend and mold without breaking, and that's how it happened. Well, here's the problem. If that were true, that heat and pressure should have actually transformed the rock into quartzite or marble. But the rock is not quartzite or marble. The rock remains sandstone. So their explanation of, yeah, we just kind of melted the rock, doesn't make sense. They don't have an explanation for this. It makes far more sense that perhaps, I don't know, a catastrophic event like a flood with rapid deposition of all layers, just like working with wet concrete, and allows this folding while still wet, makes far more sense. So think of it like concrete. You've got concrete you're working over it for a couple of weeks basically during the flood, as opposed to hundreds of millions of years with dry rock. Make sense? All right. So let me point out one other thing on this bent rock layers. Now, the rock that was bent over the fault lines called Bright Angel in the post-flood era. So these two arrows are areas where represent this area here, where there was actually a fault line post-flood that moved the canyon, and what happened? The rock shattered. So in post-flood era, so we're supposed to believe from the secularists that it didn't shatter the first time, but then this fault happened and it did shatter that time. What's most interesting to me though, and I'm going to back up a slide or two here to, let me see if I can, remember this is the bottom layer. The creationist or biblical theory here is that this is the rock that was laid down pre-flood. This is God's created earth right here. These are the layers that were laid down in the flood. And what we find is that the granite layer that was laid down at the time of creation did break in the Grand Canyon. And so again, it makes far more sense that the granite layer, that base layer, was present at creation, and then all the other layers were laid down at the time of flood. So, as far as putting together geology and the theory of uniformitarianism, keep in mind the Bible clearly says the earth was formed supernaturally and catastrophically. Secular quote-unquote science claims the earth was formed naturally and uniformly. I obviously reject this latter view of uniformitarianism, but let's go ahead for a moment and grant the latter theory, the uniformitarianism, the present is key to the past, and let's examine some geologic processes in that light. Before I do that, any questions on what I've covered so far? Perfect. So what I'm going to do here is we're going to take the secular view of things, that everything occurs uniformly at a constant rate over a constant period of time, and let's apply that to some processes we see today. So let's look at sediment on the seafloor. Every year, about 20 billion tons of dirt and rock debris from the continents is dumped by the rivers and other things onto the seafloor in the ocean. About 1 billion of these 20 tons is lost due to the shifting of tectonic plates, so we ultimately get 19 billion tons per year of sediment being deposited into the ocean. The current depth of sediment on the ocean floor is 1,300 feet. At the current rate of deposit, this 1,300 feet would have been accomplished at 12 million years. rather than 3 billion years secularists claim the Earth had existed in its current form. So again, using the uniformitarian model of how fast people go, or I'm sorry, how fast debris comes, excuse me, we would only be 12 million years old. Once again, a much better explanation is that a global flood caused massive amounts of erosion and sediment deposited at that time in a short period of time. So most of those 1,300 feet came during the flood, and now we're seeing a very slow rate, which makes sense. Catastrophic event, catastrophism, and then we've got a uniformitarianism that's adding just a little bit. Let's look at salt in the ocean. Every year, rivers, glaciers, volcanoes, underground seepage, and atmospheric dust deposit about 458 million tons of sodium into the ocean. So ocean salt, or all salt that we eat, is sodium chloride. So we're dumping this sodium into the ocean, which forms the salt in the ocean. Now, of that 458 million tons, 128 million tons is removed through natural processes that I'm not going to quite get into. But let's assume the ocean started with no salt. To get to the ocean's current level of salinity, you'd reach that at 42 million years. Nowhere near the 3 billion that they tell us the Earth is. Once again, much better explanation. God created salt oceans. They got much saltier with the flood. How about rocks on the surface of the Earth? The Earth's crust is made up of rocks similar makeup to materials deep in the Earth. What happens is you've got these rocks deep in the Earth. Volcanic activity spews this material to the Earth's surface, and then our crust, the crust of the Earth, is formed from this. New material to this crust is added at a rate of 4 cubic kilometers per year, and the current composition is 5 billion cubic kilometers. This would suggest the Earth can be no older than 1.25 billion years old. Again, far less than what the secularists tell us it currently is. Now that assumes you start with zero crust. God obviously would have created a crust to the Earth as a starting point, and likely volcanic activity was far greater around the time of flood. Again, catastrophism far better explains these processes than uniformitarianism. Let's look at erosion of the continents. Erosion cuts away at elevated surfaces like plateaus. Again, this is how secularists explain the carving of the Grand Canyon. A plateau is a raised level of rock. The river comes through and slowly cuts through there. So we know that erosion occurs. The current rate of the cutting, or the erosion, that occurs on the Earth is about 27.5 billion tons of sediment per year. So at this rate, all of the continents should be at sea level in 14 million years. Okay, so I wouldn't have been able to go to Colorado last week, or it would have been pointless, because I might as well be in the middle of Kansas. No offense. And so this is a far cry from the 3 to 4 million, or billion, typo there, billion years old that the Earth is supposed to be. So in summary, looking at geology, clearly geologic processes can occur much faster than what we're told by the secularists and do not require millions of years to occur. A catastrophic flood, as is described in Genesis, clearly explains almost all of what we observe in geology, far better than uniformitarianism. In fact, as we just discussed, applying uniformitarianism creates all kinds of problems for old Earth theory, as the Earth cannot possibly be as old as we've been told. Questions on geology? Perfect. Well, Dave's not here to call me out on astronomy, so I'll see if I can get away with this next section. All right. So let's look at astronomy and some of these same processes that we looked at in geology. Let's apply them to astronomy. So last week or 2 weeks ago, we discussed the Big Bang and all the issues with it. We discussed numerous explanations for light years and the basic astronomical processes that exist. Now, I want to apply the uniformitarianism model to these astronomical processes and see how they check out with the age of the universe that the secularists tell us is out there. So let's start with the moon. There are lots of secular theories about the formation of the moon. There was, in the 1970s, they told us, well, we captured the moon by Earth's gravity. And then in the 1980s, they said, no, that's not what happened. It was a collapse of some sort of dust cloud or star nebula, and that's what formed the moon. And then more modernly, they said, no, you guys are both wrong. What happened was the Earth collided with something like Mars and chipped away a piece of the Earth, and now we have the moon. So, again, what's that? Yeah. So, now again, like I've told you in the past, in the 1970s, all of those people would have told you, you Christians are crazy. We know that the moon was captured by the Earth's gravity. In the 1980s, they would have said, you Christians are crazy. We know it was a cloud dust. And then modern times, they'll tell you, Christians are crazy. We know it was a Mars object that collided with the moon. Well, their theory changes over and over and over, and once again, our theory never does. God created a nightlight in the beginning. He was clear on this. Now, the moon itself is very, very interesting and actually shows a lot of interesting design properties, almost like an intelligent being put it in there. Lunar tides, we're all familiar that the moon causes the tides of the ocean. Well, actually, these lunar tides help keep the ocean healthy. Also, the moon helps stabilize the Earth's tilt and seasons. I'm sure we all remember from Earth science that the Earth doesn't sit like this, it sits like this, and we have to stabilize that tilt. And the moon actually helps stabilize that tilt. And most importantly, the moon's a nightlight. God said he created light for the day and for the night. The moon is also a compass, a clock, and a calendar. The moon has many, many uses, again, almost like an intelligent being designed it. So let's talk about moon recession. The moon is slowly pulling away from the Earth, and this actually results in a very, very faint slowing of the Earth's rotation. As the moon pulls away, the Earth rotates ever so slightly slower. And we know how fast the moon is moving away. It's currently moving away from the Earth at about 1.5 inches per year. So it ain't going anywhere anytime soon, but it is moving away. What does this mean? Let's go back 1.5 billion years. Now the moon is touching the Earth. Think that's possible? So secularists tell us the Earth and moon are 4.5 billion years old, and life on Earth started 3.5 billion years ago. So you think everybody was walking on the moon? No. Actually, the Earth could never touch, the moon could never touch the Earth. Once it actually got close enough, Earth's gravity would break up the entire moon, and we would end up with rings, just like Saturn has. So it's not even possible that the Earth, even if you wanted to say the Earth could have touched the moon and escaped, it's not possible. It wouldn't be there. Let's look at Earth's magnetic field. So the magnetic field is very important. It actually protects us from solar radiation. It is actually critical to life in many ways. And we can measure the strength of the magnetic field. Measurements actually started in 1835. And what they found by serial measurement, by measuring it each year, is that the strength of the magnetic field is decaying fairly rapidly. Its half-life is 1,400 years. I don't remember if I've covered this before, but half-life means how long does it take for something to be cut in half. So when we talk about the half-life, think of it as a half-life of a cake. You're going to leave a cake out at your house. How long is it going to be before it's half gone? And then half gone again, and then half gone again. Probably depends on how many kids you have at home. At my house, it would be much shorter than probably some of your house. But half-life is how long does it take for something to be cut in half. So the magnetic field is cut in half every 1,400 years from its initial strength. This implies that this magnetic field will eventually be gone. And it'll essentially be gone by the year 10,000. This also implies the field was a lot stronger in the past. Well, let's go back 100,000 years. What do we get? We're a neutron star, not a planet. If you go back just 20,000 years, this would have made the Earth too hot to be covered by water and would have disrupted the Earth's internal structure. The magnetic field alone suggests that the Earth can be no more than, say, about 10,000 years old, and God has a plan to probably end it before 10,000. I'm not saying I know when the Earth is going to end, but just throwing it out there. Let's look at comets. What are comets? Well, remember, space is very, very cold. We talked about that a couple weeks ago. It's just barely above absolute zero. So comets are a frozen collection of ice and rocks and dust that travel through the solar system, and they make loops called orbits around the sun. So the comet circles the sun. And these range from a few to tens of miles wide. Well, as these frozen collection of ice gets close to the sun, they actually start to melt, which makes sense. And they spew all this dust and gas. and from the head, and that glows, and that's what you see as the comet. So you've got the tiny little head here, and as it's melting, basically, it's throwing off this tail. Well, as you can imagine, if you take a big chunk of ice and you run it by the sun, the size of your ice cube will melt. It'll be smaller over time. So each time a comet rotates past the sun, it's shrinking the size of the comet. So we know that dozens of comets orbit the sun each year, but over time these comets lose their energy and they're eventually ejected from the solar system. They collide with the sun or other planets, or they become so small they break up into fragments. So we know these comets have some sort of lifespan to them, if you will. And then when these break up, interestingly, you get these clouds of dust. Is a side note, dusty debris, if you will. And when the Earth passes through it, that's what we're actually seeing as shooting stars. And I actually learned that just doing this talk. I always thought we're seeing a true shooting star, but you're seeing dust from comets. Now, the average lifespan of a comet around the sun is 40 trips, and scientists call these periods. So you get 40 trips roughly around the sun before the comet becomes so melted that it's gone. And there are two types of comets out there. There are what are called short period comets, which are comets that we see more frequently than every 200 years. And then there's long period comets, which are ones that orbits are so large we only see them every few thousand years. Well, the supply of both of these comets, and definitely the short period comets, they should all be used up by now. A long time ago they should have been used up, but they clearly are not. At best, these things would allow for a few million years for these comets to exist. Halley's Comet, which is probably the one we're all familiar with, that was actually observed going back as far as 240 BC, which means Halley's Comet has already made 28 trips at least. And so Halley's Comet is probably on its last couple legs, so enjoy it if any of us are old enough or can live long enough for the next time. So what do the secularists tell us? How do they answer this? Well, it's simple. They said, look, there's this thing called the Kuiper Belt where we get our short period comets, and it's just beyond Neptune. And then way out there is something called the Oort cloud that's way beyond Neptune, and that's where our long period comets come from. And occasionally, these areas, the Kuiper Belt and the Oort cloud, just inject or throw a comet into our solar system. Makes total sense. So here's the problem with the Kuiper Belt. The only objects we can see in the Kuiper Belt are way too large to be comets. Do you know why Pluto's not a planet anymore? Because it's actually part of the Kuiper Belt. It's actually just a rock that's part of this belt, and that's why it's not a planet anymore. And their composition of the things in the Kuiper Belt is far different than the composition of comets. We can't actually see anything comet-sized in the Kuiper Belt even if we wanted to with current technology. It's all an assumption. They say, well, there's a lot of big rocks out there must be some small rocks, and that's where the comets come from. And that's the short period comets, the fast ones like Halley's Comet. What about the long period ones, the one that come from the Oort cloud? Well, there's only one problem. There is zero evidence for its existence. There was a guy named Jan Oort who came up with it and said, there it is, and now we all know the Oort cloud's there. Except nobody can find it and it's just theoretical. Once again, it comes back to non-falsifiability. When you run into a problem, you just invent a solution. Let's look at something called the faint sun paradox. Nuclear fusion is what causes the sun to heat up. Hydrogen, as you recall, the very first element out there, is converted to helium, which is the second lightest element. So hydrogen turns into helium, and this gradually actually increases the sun's temperature and brightness. So the problem with this is this means the Earth would have been very, very frozen 3.5 billion years ago when secularists tell us life began. And actually, geologic evidence suggests the sun was actually warmer in the past. So the fainting sun doesn't make sense with current explanations. Let's look at spiral galaxies. I think we've all seen pictures of spiral galaxies. This is a very common composition of galaxies in the universe. You've got a central core, and then you've got outstretched arms here. Very pretty. These arms, as you can see from this picture, are composed of blue stars. Blue stars actually burn their fuel very, very quickly, and they cannot last billions of years. So the fact that we see blue stars, the fact that we see the arms in these spiral galaxies, argues strongly for the fact that the universe cannot be billions of years old. Well, once again, what do the secularists tell us? They tell us the new stars are formed constantly. We don't have any evidence for it, but that's what happens. And and actually, the compression of gas into stars has to overcome several principles of physics, which would actually make this very difficult. Once again, comes to non-falsifiability. You just invent a solution. Well, there's a second problem with spiral galaxies. These galaxies are actually constantly winding themselves up and becoming tighter. And actually, if you do the math on this, in less than 1 billion years, all the galaxies should be twisted to the point where the arms are no longer recognizable. Those arms are getting smaller, and they should have come into where they're not arms anymore. So, what do the secularists tell us? Well, these new arms are formed to replace the old twisted up ones. Numerous problems with this theory. The biggest one remains, as this has been the theme, there is absolutely no evidence for star formation. So in conclusion on astronomy, our understanding of astronomical principles is constantly changing. However, it should be clear, as in many of the areas we've studied, secular scientists are often starting with their conclusions, explaining away contradictory evidence with new theories that have no basis in observable or reproducible data. Furthermore, using their own assumptions, we can show many different ways the universe is younger than they propose. This is the uniformitarianism we've been talking about. If we just simply go with their explanations, it makes no sense. The biblical explanation for the origin of the universe fits far better with what we observe today. Questions on astronomy? Yes, sir. Oh, yeah. Mm-hmm. Yeah, you'll hear news reports like that all the time. So, yep, anytime you watch it, they'll always tell, and they always know exactly how old it is, how far away it is. No, it's a great point. Yes, I'm sorry. Yes, sir. Good question. Did not specifically look into it. Black holes are more theoretical. I don't know if anybody's ever fully demonstrated the true existence of a black hole, but I am not an astronomy expert. So if you have a good explanation of it, fire away. Okay. Yeah. No, black holes are used often to explain some of the problems that people that people see in astronomy when they can't explain certain phenomena out there. They say, well, there's black holes that must be there. Total side note, this is an interest of my dad's, and I know almost nothing about it, but he's very into the what's called the electrical universe, which is the theory that the basic driving thing through the universe is not gravity, it's actually electricity. And electricity actually explains a lot of this better and doesn't require black holes. So, complete side note, that'll be another talk for another day. But yeah, no, good, fair question. So, lastly tonight, I want to talk about human history and how human history relates to the age of the earth. So, the Bible tells us that man was created fully formed in God's image. We were intelligent, functioning, and complete. We had no need to evolve. Then, at the Tower of Babel, we were separated into various languages and cultures. Well, evolution tells us something very different, that man slowly evolved from apes about 3 million years ago and then slowly advanced in functioning and intelligence until we got to where we are today. So, God's view, biblical view, man is created intelligent and is ready from day one. Evolutionary view, man slowly came about over 3 million years and was really dumb to start with and then slowly got smarter and smarter. Well, what's the problem with this? So, recorded history, the things we know in human civilization, are far more consistent with a biblical context, where we see multiple advanced cultures just suddenly appearing about 5,000 years ago. Boom, there's all these cultures. These cultures had language, architecture, technology. They were able to produce incredible things like pyramids and ships, and we'll talk about that a little bit more in a couple weeks. The sudden appearance of modern man and cultures in multiple places at one time is not at all what would be predicted by evolution. Remember that evolution should be a slow process, so somewhere there should be an ape-like creature that's just a little bit smarter and kind of vaguely starts over here, while somewhere over here there's an orangutan-like creature that becomes just a little bit smarter and forms its own culture, but that's not what we see. We see all of a sudden, boom, advanced cultures, fully developed. Well, let's look at population statistics. The human population currently grows at about 2% per year. So looking at that rate, it only takes about 1,100 years to get 6 billion people starting from one single couple. So what if man existed for 1 million years? Well, we should have a very large number of people. 10 to the power of 8,600. That's 10 with 8,600 zeros after it. I couldn't even put it on a slide. So yes, granted, life in the past was harsh, and there was famine, and there was plague, and that may be the explanation for why we don't see that many people. But remember that modern man ain't doing that much better either. In the last few centuries, we've witnessed some of the worst wars we've ever seen, rampant abortion rates, brutal genocides. It's really hard to argue the death rate in modern times is so much lower than it was in the past. So, let's assume that man has been present for 1 million years. So to get 6 billion people, the growth rate would have to be 0.002% to start from a single pair. That's very different than our 2% rate that we see here. But here's the other problem. That's a whole lot of skeletons that we aren't finding. No skeletons in any closets here. In fact, this number is basically the number of humans that could just barely fit into the current volume of the Earth. But those humans decomposed. Okay, I mean, that's fine, but as we talked about a couple weeks ago, remember that Neanderthal and Cro-Magnon civilization, they actually buried their dead, which results in great preservation of bones and teeth. And we're told that the Stone Age lasted about 100,000 years with a population of 1 to 10 million. Well, that should still result in 4 billion bodies. So where are they? And we actually find very few. Now, similar arguments exist for plants and animals, which we should find all over the place in the fossil record, but we don't. Let's look at man's intelligence. Look at all the modern marvels of modern society. Internet, phones, airplanes, televisions. These aren't more than 100 years old. Look at the inventions of society over the last 1,000 years. Go back to Gutenberg's printing press. Go back to the pyramids and marvel at the technology that it took to make the pyramids. Secularists tell us modern man came around somewhere between 200,000 and 300,000 years ago. So what in the world were these intelligent creatures doing for the first 98% of the time? Are we really supposed to believe that humans were just hunter-gatherers for 245,000 years, and then they did everything we know in the last 5,000? Does that make sense at all? So, concluding, oh good, I'm running time. So, in conclusion, in general, we obviously cannot know for sure how old the Earth is. But the secularist view of billions of years is obviously fraught with all kinds of holes and problems. The Bible is quite clear about the history and is basically, or is, I shouldn't even say basically, is an eyewitness account from God about his creation. So much of old Earth quote-unquote science is an abstract, unprovable hypothesis. And admittedly, this is my final thought, the best evidence for an old Earth actually lies in radioisotope dating. But that's what I'm going to talk about next week. So, what questions can I answer, if anything? Yes, sir. Mm-hmm. Mm-hmm. That's No, that's a great question. Yeah, no, that's a great question, and that's been asked. And what I'll tell you, the evolutionists will say is, we are living in such a short period of time that you will never be able to see evolution. In other words, it takes generations and generations and generations. So there's no real way for us to see. I mean, this is going to be their explanation. They're going to say modern man. All of us in this room basically we haven't really changed in the last 40,000 years. So they're going to tell you that in the next 20, 30,000 years, you're not going to see much of any change. You're never going to get that third arm you need to do that project. So they would tell you those processes are way too slow for us to see any change. And no, I've not read a specific hypothesis of what the next evolution is going to be. Again, like we talked about long ago, if the next process really should be we all turn into bacteria. But yeah, it just takes time. It just takes time. Yeah. Mm-hmm. Yeah, So Darwin wrote a book, or it's in his book, The Beak of the Finch, I think, and where he draws all these different beaks of the finch, and that is supposed to be observing evolution in real time, is seeing the different sizes and shapes of the beak and how that might equal different food and whatnot. But no, I mean, your point is well taken. We really cannot. We cannot, by definition, observe evolution in real time in anything other than bacteria, to be honest. And that's what they'll always say. It's nope, took way too much time. We're not going to live long enough. There's no way we can see it. It's a non-falsifiable hypothesis, but that's exactly right. Yes, sir. Okay. I have not. It sounds. Mm. Mm-hmm. That's a good. I don't actually know the answer to that. That's a good question. Mm-hmm. There's no way. Yeah, you're a bigot. I mean, that's what they're gonna say something like that. I mean, no, that's a great question. I mean, some of they just say, well, you're just too dumb to understand. I mean, every time I look it up, that's usually the answer. You're just not smart enough to understand. I actually am. I do have a section on paleontology, so I did not get into the college, and I may have to look into that because that's interesting. But yeah, no, the fossil. I mean, ultimately, to not to rain on my old parade down or future parade, but I mean clearly the vast majority of fossils were formed during the flood, and that's how we got fossils, and that fits exactly with what you're describing as far as the. Yeah, the flood. I think the flood has been incredible, and this is why Ken Ham in Answers in Genesis built Noah's Ark. Is I think the flood has often been. We're going to talk a lot about this, but has often been portrayed as a bunch of animals in a bathtub, and that's not what it was. It was a global catastrophic event that reshaped what the Earth is, and I think the flood actually explains far more than any of these secular theories that are out there. Good. Yes. Yes, yeah, I didn't get into that. That certainly you jump layers. So you've got your top heats, and then you go from that to the kaibab rather than having the middle layers. Yes, there is there. I didn't get into the details of that, so I don't want to comment without being ignorant, or don't want to comment while being ignorant. But yes, that is another problem that exists. Is why do we have certain layer? Why are we missing layers at some levels? Again, to me, that would be well explained by a flood that's different in different areas, right? Yeah. Good. Mm-hmm. 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 Correct. Yes, absolutely. No, that is a very good point. And I think that I have that on one slide somewhere. You're exactly right. That the oldest tree we can find conveniently dates to about how long ago we think the flood was. So yeah, no, that's a great point, and that's another fascinating argument for, again, a young Earth and the flood. All right, guys. Well, perfect. So next week is my most complex topic of the entire series. So I will, and it's a fairly long talk, so I will probably talk fast, and I apologize. But we're going to go over radioisotope dating, because this is the thing that secularists will throw at you all the time. Things like carbon-14 dating, potassium-argon dating. Really, this was probably it was the most difficult one for me to put together, but also the most fascinating. Really, really good information. There's a great group out there that's done some incredible work on radioisotope dating from a creationist view. So I hope everybody will bear with me through that one. The talks do get a little simpler after that. We're going to shift into paleontology, and then a couple of weeks on Noah's flood, the importance of the flood, the evidences for the flood, the logistics of the flood, etc., etc. So bear with me in advance next week, but after that we'll get a little more straightforward. So, good. All right, guys. Well, thanks for braving the weather, and we'll see y'all next week, hopefully.